Hello and welcome to another video in this series about object-oriented programming. In this under the hood video about class methods, so the static methods, I'll demonstrate what the effect is in memory when static methods are invoked, and focus your attention on the fact that these methods do not have a this pointer. This is the rectangle class as implemented in the hands-on video, displaying some of the class member variables, so the static variables, including the now encapsulated count class member variable, which is set to private, and the public static getCount method, just returning the value of the count. As a reminder, the count is incremented each time a new object is created. The client code I'll examine under the hood step by step in the next slide is very similar to the client code of the previous version, version 6. The only difference being, whereas the client in the previous version used the count variable directly, since it was public, in this version the client needs to invoke the getCount method in order to retrieve the amount of rectangles that were created. But the output will be the same as in the previous version. First of all, the min height will be printed out, the getCount initially will be set to 0, then two objects will be created and printed out, and finally the count will be printed out again. Let's dive under the hood and explore what happens in memory when we invoke a static method. As already explained in the under the hood video of the previous version, version 6, class data members are reserved in some kind of static area in memory. From the moment something of the rectangle class in this case is used for the first time, because that is a time when the runtime will load the class code in memory and initialize the class members. So here, executing the printf statement will trigger this allocation of static variables, since rectangle.minHeight is the first time something of the rectangle class is used. Before the print is executed, the allocations take place. Now I only display the min height. The three dots represent the other static member variables that are used for validations, so all the minima and maxima. But what I display as well is the count variable, because it's static as well, initialized to 0. After this allocation, the printf is executed, which will then display the value of the min height. For the next printf, the getCount method must be invoked first. Now, this is our static method. What does the invocation look like? As it is a method, as with any other methods that we've seen so far, instance methods, a stack frame will be allocated. So the invocation takes place, new stack frame is allocated, and unlike with instance methods, no this pointer will be allocated, since we are not using any object reference. Static members, variables or methods are preceded by the name of the class dot, so an object reference is not needed. And hence, when invoking a static method, no this pointer will be initialized. So no this pointer in the local variables array of the stack frame of the static getCount methods. And this is always the case when invoking static methods. Now, since this method will eventually return a value, because it's a non-void method, it's supposed to return an integer, space will be allocated in the local variables array for the return value. So the stack frame is set up. The only thing it does is return count. So what will happen? Well, the count is the one that is allocated in the static area, the rectangle.count. Its value is 0, and this value will be copied to the return value section of the local variables array. That's it for the method. We return back to the main. Current stack frame will be cleaned up, and this return value of 0 is actually the result of our rectangle getCount invocation. Back to the current stack frame of the main, and the printf can now print its statement, which will be 0 rects. So that's for the invocation of a static method. No this pointer available. Then the next few statements involve the allocation and printing out of two rectangle objects. Now, as I've demonstrated the details of the allocation several times in previous under the hood videos, I'll be a bit more quick here. So starting with the first one, object is created on the heap, initialized in the constructor, The count is incremented in the constructor as well, and our reference variable rect1 is referring to our object located at fictional address 1000. When we print it out, we have the same output as before. For the second object, so object created on the heap, initialized in the constructor, and the count will be incremented as well to 2, and the reference variable rect2 referring to our second object located at fictional address 2000. Printing out the object, same output as before. And then finally, we want to print out the count again. Now this is the same getCount methods, which will be invoked as I've demonstrated a bit earlier in this video. Since the count is 2, this is what we see in the output, 2 rects. Okay, so that's it for this video, and the thing to remember here is that static methods never have a this pointer. If you like this video, thanks for pressing the like button or subscribing to my channel. See you in the next version when I'll talk about initialization blocks. Bye bye.